Here we are then looking at question 13 of this chapter 14. Okay, review exercise or mixed exercise. So, question 13. What do we have? Radioactive decay of a substance is given with R equals 140 e to the power kt. Okay, and T is time and it's greater than 0, where R is the measure of radioactivity at time T days and K is a constant. Explain briefly why K must be a negative. Because radioactive decay is going down. Okay, so we have to have a decrease in. If we have something like Desmos, let's get Desmos open here and we'll see what we've got. Let's have a new thing. Right, so here's Desmos, just a graphing software, and if we take something like what was it, 140 e to the power kx, I'm going to have to put in just so it can plot it, and we're going to have a slider for k because it's constant. Okay, when k is 1, you can see the graph there is continuing and it will just keep on moving around there like that. But as soon as we go into the negatives, okay, with the k, you can see then that we have a radioactive decay that comes downwards. Okay, so it gives that negative value of x. Okay, it should also cross up here at 140 depending on any of the just about see it there, on any of the values for k. It's always crossing at 140 because that's where it starts its decay. It's going to be 140 years coming down and we want it to go in. It's got to be a negative so that it comes there. I don't think it doesn't sit in this quadrant at all. No, so in the negative there you can see so that you get the decay profile that you want. Okay, so to list that up in a sentence, we can say that k has to be negative to make the graph of R a decreasing exponential. Okay. There we are. Okay, so part B then, they are asking us to, part B, sketch the graph of R against T. Well, since we've just had it open on Desmos, that's going to be straightforward to us. But it's a decay graph. Something like that. And we're going to have that coming down here like this. And that's going to be 140. This is R, 0, and T. And that's about it. Really, there's nothing more to add into that. Okay, T. Okay. Now then. After 30 days, the radiation is measured at 70. Show that K is this, starting with the value C. So, we have been told that when T, this is part C, we have been told that when T is equal to 30, then R is equal to 70, so we can put it into the equation. 70 equals 140 e to the k 30, so I'm going to write it as 30k. Quickly solve that for k then. Let's do 70 divided by 140, that gives us a half equals e to the 30k. And so let's take the ln of a half is equal to 30k. Divide that by 30 and we get k is equal to ln of a half over 30. Okay, so they want it as k is equal to c ln 2. So how can we get that out as a constant, and how can we get that as a 2? So k is equal to the ln of 2 to the minus 1 multiplied by 1 over 30, and k is equal to minus 1 over 30 ln 2. Thus, therefore, they've got c is equal to minus 1 over 30. Okay, we've got that negative number as they asked for in the start of it. Show that stating the value of the constant c. There you go. All